Okay, we have here another application problem. Once you decipher this picture and you understand what the triangle is you're trying to solve, it's probably not going to be that bad. The law of sines application is not tough in this one. But the difficult part looks like I'm seeing this triangle here, okay? I can clearly see there is a triangle there on top of that hill. And I'm only given an angle and a side. And I've been telling you guys you need three things. You need a pair of opposing angles and sides, and you also need one more thing in that triangle, and this triangle's only got two. So we're going to have to use something else in this picture, and I want to just point you to this angle that we're given, which is clear outside the triangle. Okay, how do we get that to be more relevant? Well, let's imagine you have a triangle right here also. Okay, sort of inside the mountain right there. That's a right triangle, the way I've drawn it, because we go vertically straight into the ground. And if that's a right triangle, then I'm going to tell you guys that you can solve for this angle theta that I just drew right there. Okay, right there, theta is going to be equal to, 180 degrees is the total of a triangle, minus 90 degrees is the right angle, minus 61 degrees. Okay, so what do we get? We get 180 minus 90 minus 61, 29 degrees. So I know that theta is 29 degrees. Great. Now take another look at this. If I label this thing right here phi, how do we find phi? Well, it's supplementary to theta. Okay, it's on the other side, and the two of them added together have to be equal to 180, right? Because it's a straight line. So what do we get? We do phi equals 180 minus theta. So 180 minus 29 degrees equals 151 degrees. Okay, so that's really important because now we know two angles and one side inside this triangle. Let me redraw it because that picture is getting a little messy here. Here's the triangle I'm given. We know 7 degrees, and we know 151 degrees over there, and we know this side is 148. So now you're thinking, okay, great, well, I've got three things, but none of them are a pair, right? I don't have a pair of opposing angles and sides, and that's true. So you might think, well, we don't use law of sines, but I'm just going to point out, whenever you have two angles, you can use the law of sines. Even if one of them isn't matching, we can find this last angle up there, because all angles in the triangle have to add up to 180. We do, let's label this third one right here. I'm going to label this beta. Okay, so beta equals 180 degrees minus 151 degrees minus 7 degrees. That means beta equals, what do we have for 180? 180 minus 151 minus 7. Okay, so we get 22 degrees. Super. Now, what did we actually want in this problem? We wanted the length of that wire. Okay, let's call that, I don't know, X, I guess. I'm not using the same letters that I normally do with the A's, B's, and C's, and that might be a little confusing at first, but just think of it in terms of sides and angles. Okay, if I rewrite the law of sines, which, here, let's just put that here. For this case, I'm going to want sides on top. If I said little a over sine A equals little b over sine B, well, those are sides, and let's just put in the values we know and say x is a. Okay, so that's going to be x divided by sine of its opposite angle, 151 degrees, equals, pick something we know. How about b, 148, and the angle opposite b is 22, so that's going to be sine of 22 degrees. So I want you to stop here and really make sure you understand why I assigned those variables as I did. Okay, here's an opposing pair, 148 and 22 degrees, and here's another opposing pair. Okay, this is the one I'm solving for, x and 151 degrees. So now we just go through this and solve. X equals 148 times sine of 151 degrees divided by sine of 22 degrees. Okay, so what do we get? 148 sine of 151 divided by sine of 22. we get that the guy wire in this problem is going to be 191 yards long, okay? So the only trick I think about this one is realizing that information outside a triangle can be useful to finding out something inside the triangle. And then it's just a matter of applying your law of sines and you're done.